Experiment number 1B from Design and Analysis of Algorithms Lab is to write a Java program to implement a stack using arrays and write push, pop and display methods to demonstrate its working. So here we have created a class called stack which has a variable member called as max whose capacity is to hold 100 elements. It is defined as the type final so that its value cannot be changed. And then we have declared a single dimensional array S with a capacity to hold 100 elements in it. So we are going to implement a stack using array. And then top is initially set to -1. So as we know that in case of stack, whenever we want to insert an element into a stack, top has to be incremented first and then you place an element onto the top. That is, in case of a stack, both insertion and deletion happen at the location called as top. So then we have a member function called as push which takes one input parameter called element and if the value of top is greater than or equal to max -1, we check this condition before inserting an element into the stack. So if top is already equal to max -1, it means that the array is full. So therefore we simply print that the stack overflows or stack is full. Otherwise, if the condition was false, then we jump to the else part of it, wherein we first increment the value of top, that is plus plus top, and then in the array at the location s of plus plus top, we insert the element into the stack. And then we have a method called as pop. In method called as pop, we have declared a temporary variable z which is set to 0. So before trying to delete an element from the stack, we are supposed to check if the stack is empty. So it is done with the help of the condition if top is equal to -1. So if top is equal to -1, it says that the stack is empty. So simply we print stack underflows and exit from the program. Otherwise out, we jump to the else part of it, collect an element that is at the location s of top, put it into the variable z and then decrement the top value by 1 and return whatever is available to us in the variable z. So this is how we remove an element from the stack. Similarly, we have a function called as display. So it is going to display the contents of the stack. So before you try to display the contents of the stack, check if the stack is empty. So the condition here is if top is equal to -1, then the stack is empty, come out of the function. Else what you do is you start a for loop right from I is equal to top, that is the last element into the lastly inserted element onto the stack, and go on decrementing the top value until it becomes equal to -1. So when it becomes equal to -1, it means that you have already printed all the contents right from the top location till the 0th location using system.out.println. So then there is a main method in the class called a stack, wherein we have declared a temporary variable called as q which is initially set to 1, and then we have created an object called as m which is of the type class stack using the dynamic operator new, and then we have created an object called as SC, which is of the type scanner, to read the input parameters. So while q not equal to 1, while q not equal to 0, it is as it is q's value as we have already set to 1, the condition becomes while 1 not equal to 0, similar to that of while 1. So this while loop would be running infinitely. So inside it we have written a sysout statement which says that one will stand for a push operation, 2 will stand for a pop operation, 3 will stand for a display operation, and any other number if you enter, it is going to exit from the program. So then the next line would ask the user to enter his choice. So to read his choice, we have declared a temporary variable ch whose value is read by making use of the scanner object. As ch is an integer, we make a call to method nextInt. So then switch according to the choice. So if choice is 1, the control would jump to case 1, wherein case 1 is making a call to push function. So in order to push a element, you first have to read this element. So therefore we have declared a temporary variable called as ELE, and we are reading its value from the user using the scanner object and the method nextInt. As soon as the element is read, we make a call to method push, which belongs to object m, as m is an object of the type stack class. So m dot push whatever is the element read. After pushing the element onto the stack, break out of case 1. So you come out of switch. Similarly, for the next time, if the user enters his choice to be 2, then you are trying to remove an element from the stack. So when you remove an element from the stack, pop is returning a value. So you need a temporary variable to hold it. Therefore, we have declared a variable called as pop ELE of the type integer. Pop ELE is equal to m dot pop. So you are making a call to pop method here. Whatever value is returned will now be stored into pop ELE, and once it is done, using sysout statement, you are trying to display the content that is being popped from the stack. And case 3 is where you are trying to display the contents of the elements on the stack. So you just have to make a call to display method using the object of the type stack. So m dot display will do the needful. And then case 4 is q is equal to 0. So if you press any other number, if you press number 4, then q becomes equal to 0, which helps us come out of the while loop. So this is the program to insert the elements, to push and pop the elements from the stack. So let us see how does this program run. So this is the output screen. It is asking us which operation we would like to perform. 1 stands for push, 2 stands for pop, 3 stands for display. So let us say we want to push an element onto the stack. So the element to be pushed, let me say I want to push 12. Second time also, I again want to push an element onto the stack. So let me say I want to push 34 onto the stack. So let us see how many elements have we pushed onto the stack. So let us make a call to display function there. So first value inserted was 12 and the last value inserted was 34. So 34 is on the top of the stack. So now let us make a call to pop function. So whatever is on the top of the stack should be deleted first. So it means that 34 has to be deleted first. So let me enter the choice to be 2. So the first element popped is 34. Similarly, let us again pop the second element. So the second element popped is 12. So now, even if I pop, there are no elements. So let us make a call to function display and see how many elements we have onto the stack. So it says that the stack is empty. So this is how the program runs.